So how we can prepare the alkenes? Let's have a look on the methods for its preparation. Basically, for the preparation of the alkenes, as alkene, it is a unsaturated hydrocarbon. Unsaturated hydrocarbon. Unsaturated hydrocarbon means it is having a double bond between two carbon atoms. And we can prepare the alkenes by the use of basically two methods. The first one method is dehydration of alcohols, and the second method for the preparation of the alkenes we have dehydrohalogenation of alkyl halides. Dehydrohalogenation of alkyl halides. So basically these are two methods for the preparation of the alkenes that we use in the industrial level. So let's have a look on the first method, that what does mean by dehydration of alcohols. So dehydration of alcohols, dehydration means removal of water. So we are going to dehydrate the alcohols. So it will be the removal of water from alcohols. So dehydration of alcohols, it is basically a process in which alcohol undergoes the loss of water, and there is a formation of double bond between the two carbon atoms. So double bond will be formed between the carbon atoms. In this, we have an example where we will prepare the ethene by dehydrating the ethyl alcohol. Ethyl alcohol. So you must need to remember that which alkyl radical is gonna to be having the alcoholic group, this carbon number atom will be same. If here is ethyl, then we will get ethene. If there is propyl alcohol, then we will get, if there is propyl, then we will get the propene. Likewise, if we having the butyl group, then we will get the butene. So this is the simple method. Let's have a look on the reaction for the dehydrohalogenation of the alkyl halides. But before that, we must have the reaction for dehydration of the alcohols. So the reaction for the dehydration of the alcohols we have a simple alcohol like two carbon atoms. This is the ethyl alcohol, CH3 CH2, and it is having a hydroxyl group OH. We will use the dehydrating agent, and here the dehydrating agent we have H2SO4, and the temperature will be 180 degrees Celsius. When these conditions are going to be applied on the ethyl alcohol, then there is a removal of water like OH from this carbon and the hydrogen from this carbon. Next, there will be a formation of the double bond. So at the end, we just gain the two carbon atoms. They are having two hydrogen atoms, this, and it is having these two hydrogen atoms like this. And here the removal of H and OH group, we will gain water H2O, and there is a formation of the double bond. So this is the simple ethene that we just gain from the ethyl alcohol. So this is the ethyl alcohol. If simple, we can write this formula like this: CH3 CH2 OH, and after applying these conditions we just gain CH2 double bond CH2. This is the ethyl alcohol, and this is the ethene. and the conditions are same, that is we're using dehydrating agent H2SO4, it is sulfuric acid, and temperature over there is 180 degrees Celsius. After that we have the second method for the preparation of the alkenes. It is the dehydrohalogenation of the alkyl halides. So the mean of dehydrohalogenation of alkyl halides is, basically you must know what are alkyl halides. Alkyl halides. Basically, alkyl halides are formed when an alkyl group is having the halogen atom. For example, alkyl radical we have ethyl, and the halogen we have, it is chloride. So we have ethyl chloride. It is shown by Rx, where R is the alkyl group and the X is the halide group. So ethyl radical. What is going to be happen? Dehydrohalogenation means D means there is a removal of hydrogen atom and the halogen atom. So basically dehydrohalogenation, it is the removal of hydrogen and the removal of halogens, where we have the halogens of four like fluorine, chlorine, bromine, and we have iodine. These are the four halogen elements. They will there is a removal of hydrogen and halogen atom from two adjacent carbon atoms. For example, if we have ethyl chloride, then we will get the ethene. Ethyl, the radical will produce the same number of carbon atoms for the production of the alkenes. So let's have a look on the chemical reaction for the dehydrohalogenation of the alkyl halides. For example, we have an alkyl radical ethyl, that is CH3 and CH2. So this is the ethyl and it is having one chlorine atom. So this is the ethyl chloride. Its name is ethyl chloride. This is the structure formula. We can also write it in the condensed formula like CH3, then we have CH2 and Ca. Now the reaction is going to be takes place, and the reaction will takes place in the presence of alcoholic KOH. Alcoholic potassium hydroxide. This is the base. Now what is going to be happen? Now this chlorine atom and this hydrogen atom from two adjacent carbon atoms will be removed by this alcoholic KOH, and there is a formation of the double bond. Next we have like C, these hydrogen atoms H2 double bond. Next we have this CH2 group. So there is a formation of the ethene from the ethyl chloride. Plus there is a formation of HCl. A hydrogen and Cl will form the hydrochloric acid. And after that, this HCl will react with the potassium hydroxide, and there is a formation of the potassium chloride plus water. So this is the simple reaction that is going to be take place between the ethyl chloride and alcoholic KOH. So ethyl chloride is used for the production of the ethene. This reaction is known as dehydrohalogenation of the alkyl halides. You can also prepare, we are going to use the propyl chloride, then the propene will be formed. If we are going to use the pentyl chloride, then pentane will be formed. So this is all about our today's lecture. I hope you guys understand, and if you have any queries, you can ask me about that in the comment section. For that time, have a good day and Allah Hafiz. Thank you.